Alright, this is my last video on atomic structure, and I wrote this as a little reminder to myself that I want to cover everything I want to right here, the rest of it. In previous videos, we talked about the atomic mass, and that told us that in nitrogen there are 7 protons, okay? And the protons are the thing that um, identifies the atom. So it has 7 protons, and nitrogen has 7 protons. Looking at the atomic mass, we can figure out that it will have 7 neutrons. And that's the typical nitrogen atom, 7 protons and 7 neutrons. But we said it could also have maybe 8 neutrons, or maybe even 9 neutrons. And but it has to have the same 7 protons. And a nitrogen atom with different numbers of neutron than the norm are called isotopes. Okay, and so the mass is going to be either heavier or lighter depending on the number of neutrons. All right, what we're going to talk about now is what if the nitrogen atom has, let's say it has 7 protons because it's a nitrogen, and it has 7 neutrons, but the number of electrons are different. Let's say it has maybe 8 electrons. Okay, so normally what we would have is 1, 2, 3, 4, 5, 6, 7 protons, and we'll have 1, 2, 3, 4, 5, 6, 7 neutrons. And then, let me see if I can get a good color here. Um, Sorry, let's try this. And then we have 1, 2, 3, 4, 5, 6, 7, but instead of just having 7, we have an extra one. We have an extra electron. So we have more, one more electron, one more electron. So it becomes more negative. So if it's more negative, it's not just a nitrogen atom anymore. It's something called a nitrogen ion. It's a type of ion. Okay, and an ion has not the normal amount of electrons, just like an isotope doesn't have the normal amount of neutrons. So it would be a nitrogen ion, and it would have a -1 charge. Okay, because it's one more negative charge to it, so it's -1. All right, and then the other side of the coin, let's say let's go backward a little bit, get rid of this writing, and so instead of it having 1, 2, 3, 4, 5, 6, 7, we have one less. We have 6 electrons. So what if we had 7 protons, 7 neutrons, and then only 6 electrons? All right, so it is 1 electron less. So it's less negative. Less negative. So when something is less negative, it becomes more positive. So this would be a nitrogen ion, but it would have a +1 charge. All right, and if it had maybe 2 less, if we had 2 less, and this wasn't here, if we had 2 less, then it would be a +2 charge. I think you get the idea. Okay, so there's an easy way to remember this, that we have um, there are two types of ions. Okay, one's called a cation, and then the other one is called an anion. And the anion is the negative charge. And so you take the an and you think a negative charge and an ion. So anion is an ion that has a negative charge. All right? And then the cation would be the positive charge. All right, one final thing, and I'll try to talk about this really quick. I don't like going too much past 5 minutes. Talked about the nucleus. All right, so we have the nucleus of an atom, and then protons and neutrons, and then the electrons are out here somewhere. But the thing about it is that the electrons and the are so far away, the size of the atom compared to the size of this nucleus, it's not like the electrons are really close. Okay, it's far different from that. This the atom itself is basically all space. All right, like almost all empty space. So if we had like a football field, and that was the size of our atom, then our nucleus would be the size of something like that. Right? So, I mean, we're talking about an enormous amount of space compared to the size of the nucleus. So, the nucleus, even though it holds, just about all of the mass of an atom, is extremely small. It's remarkably small, and the atom itself, I mean, the rest of the atom takes up this huge space, right? Where the electrons are circling or popping in and out, and the size of the atom itself is mostly empty space. Now, if you think about that, that's kind of a wild concept because, we think about, the chair that you're sitting on, the table that you're writing on is made of all these atoms, but these atoms aren't really solid. These atoms are made of just empty space. Okay? So, I mean, the theory and the ideas behind these concepts can really, be hard to understand sometimes, or just amazing to think about. And you know what? I think I lied. I think eventually we're going to end up with more one more video on atomic structure. Okay, so that one's going to be about how the electrons move, and that's kind of an important one. So sorry about that one. I gotta cross this one off. One more. All right. Hope to see you on the next one, and hopefully that will be the last one.